I think this is good. Yeah. लाइट भी ओके ही है. I think. हेलो. यप. भाई आज बहुत क्रेजी क्रेजी चीज़ हुई है. जैसे कि मैं तुम्हें दिखाता हूँ क्या क्रेजी हुई है. I don't believe these people are doing what kind of crazy shit. Da-da-da-da-da. Da-da-da-da-da-da-da. Yeah. This. भाई I was so amazed ये देख के. और इसका मैंने सिमुलेशन देखा था अभी AI स्टूडियो पे इस रोबोटिक्स वाले का. वर्ल्ड APA a platform worldlabs.ai. What the World API enables. Instead of creating 3D environment as a static asset or standalone tool, the API allow world to be generated on demand and embedded directly into the product and flow. Each request produces a complete 3D world that can be explored, shared, and built on. This approach lowers the barrier to spatial creation, open workflow that were previously slow, expensive, or out of reach. The API is designed to feel familiar to the developer while remaining approachable to the broader audience. At a high level, using the API means submitting a world generation request, receiving a fully navigable 3D environment. In return, the world generation run asynchronous, work across the range of inputs, including text, images, and videos. Input text हो सकता है, image हो सकता है, video हो सकता है. There is no special setup, no proprietary tooling required. World integrates naturally into modern application for developer. World creation building block that can be triggered programmatically. ठीक है. Marble was created around a simple idea. World Marble should lift whatever signal you have into a full 3D understanding of space. With this world API, the idea become practical. Developer can generate world from text, single image, multi-image layer, 360 panorama. Each could return a 3D navigable world that capture layout depth. What became possible? The world API is already being sold across a range of domains below the 3 world gaming. काफ़ी crazy है. Platform like SKPI are using the World API to turn 2D filming into navigable 3D environment. A single video can generate both spatial world viewing experience embedded within enabling. This is crazy now. In robotics and AI, progress is limited by lack of training data and plausible evaluation environment. Simulation play a critical role, but building a large number of diverse environment by hand is slow. काफी crazy भाई. This environment can be integrated into modern simulator like NVIDIA, Isaac Simulator, Mojoko, and RoboSuit. Research collaboration with teams like Light will demonstrate how scalable world generation enable architecture and design. But ये लोग करते कैसे हैं? Let's see.
And precision over their shots, and this is where Word Labs. But there are these times when filmmakers really want absolute control and precision over their shots, and this is where Word Labs comes into place. So we added this functionality that lets a filmmaker take any image and turn it into a world model using Word Labs API. So all I have to do is go and click generate a splat. In about 5 minutes, the splat is back. I already have one here that's generated for me. All I have to do is enter the world, and in about 10 seconds, immersive space is going to load up for me. I can use keyboard shortcuts to navigate, but I can also move around with my mouse. And essentially, I have a viewport here. I can change and use different focal lengths or camera lenses. And when there's a specific angle that I like, all I have to do is click capture take. And what this is going to do, it's going to run this viewport through our own like AI pipeline to essentially render this specific view in 4K resolution. But there are these times when filmmakers really want absolute control and precision over their shots, and this is where Word Labs comes into place. So we added this functionality that lets a filmmaker take any image and turn it into a world model using Word Labs API. So all I have to do is go and click generate a splat. In about 5 minutes, the splat is back. I already have one here that's generated for me. All I have to do is enter the world, and in about 10 seconds, immersive space is going to load up for me. I can use keyboard shortcuts to navigate, but I can also move around with my mouse. And essentially, I have a viewport here. I can change and use different focal lengths or camera lenses. And when there's a specific angle that I like, all I have to do is click capture take. And what this is going to do, it's going to run this viewport through our own like AI pipeline to essentially.
But this is good example of how do I make my website. भाई इन लोगों ने काफ़ी कुछ कर रखा है इस पे, काफ़ी अच्छे से वो एक्सप्लेन किया है. बट कहाँ पे आता है ये ब्लॉग में है. वर्ल्ड लैब स्पेशल इंटेलिजेंस. ओ क्रेजी भाई. वर्ल्ड लैब इज बिल्डिंग द नेक्स्ट frontier of generative AI, one where model can understand and interact with the world into empower use case from storytelling to simulation. Fuck. Click to explore. Shit, crazy भाई. क्या हो रहा है? भाई this is so better than the thing I was working on. Oh my god. Shit. भाई this is too good यार. Oh. Dude, this is so crazy. This is so tough. Adding URL. Need to do something good. But this is nice, bhai. Special intelligence transfer. किसकी तो आवाज आ रही है? Special intelligence transform seeing into doing, understanding into reasoning, and imagining into creativity. Oh my god. From pixel to world. Marvel Labs. Where imaginative ideas, bold experiment, and creative flow comes into life. Explore in-depth use case studies how Marvel powered real world workflow and learn how to get started with in-hand tutorial and documentation. Bye. Unleash your creativity with Marvel. भाई हम बिक गया हूँ मैं. Too good भाई. हाँ, this thing also, the Claude thing. This guy. I think this guy did it. अभी इसने एंथ्रोपिक ने ये रिलीज किया है. ठीक है, कुछ कुछ है, इसको देखते हैं क्या है. और फिर इसके कुछ कुछ सॉल्यूशन होते हैं. मैंने पहले ट्राई किया था, मुझसे तो समझ में कुछ नहीं आया था, कुछ तो कोई शिट थी. ओके, लेट्स स्टार्ट. चेक करें हाउ टू कनेक्ट फोन. What we have learned from 3 different iteration of performance engineering take home that Claude keep beating. Written by Designing AI Resistant Technical Evaluation. Evaluation technique Evaluating technical candidates become harder as AI capabilities improve. A take home that distinguish well between human skill today may be trivially solved by model tomorrow, rendering it useless for evaluation. Since early 2024, our performance engineering team has used a take home test where candidate optimize code for simulated accelerator. Over 1000 candidates have completed it and doesn't now work here, including engineers who brought up our training cluster and shipped every model since Claude 3 Opus. But each new Claude model has forced us to redesign the test. When given the same time limit, Opus Claude 4 outperformed most human applicant. That still allows us to distinguish the strongest candidate, but then Claude Opus 4 4.5 matches even those. Human can still outperform model when given unlimited time, but under the constraint of take home test, we no longer had a way to distinguish between output of our top candidate and our most capable model. I have now iterated through 3 versions of our take home in an attempt to ensure it carries signal. Each time I have learned something new about what make evaluation robust to AI resistance and what doesn't. This post described the original take home design, how each cloud model defeated, then increasingly unusual approach I have to take to ensure our tests stay ahead of top model capabilities. While the work we do has evolved alongside our model, we still need strong engineers, just increasingly creative way to find them. To that end, we are releasing original take home as an open challenge, and with a unlimited time. The best human performance will still exceed what Claude can achieve. If you can beat Claude 4.5, we love to hear from you. Details are in the bottom of the post. I think I should try this. In November 2023, we are preparing to train and launch Claude Opus 3. We would secure new TPU and GPU cluster. Our large training cluster was coming, and we spent considerably more then we had passed on accelerator, but we didn't have enough performance engineer for our scale. I posted on Twitter asking people to email us, which brought in more promising candidates than we could have evaluated through standard interview pipeline, a process that consumes significant time for staff and candidates. We needed a way to evaluate candidate more efficiently, so I took 2 weeks to design a take-home test that could accurately capture the demand of the role and identify the most capable candidates. Design goal: take home have a bad reputation. Usually they filled with generic problem which engineers find boring, which make for poor filters. My goal was different: create something genuinely engaging that would make candidate excited to participate and allow us to capture their technical skill at a high level of resolution. The format is also the format also offer advantage over live interview for evaluating performance engineering skills. Longer time frozen engineers rarely face deadlines of less than an hour when coding. A 4 hour window later reduced to 2 hour better reflect the actual nature of the job. Still shorter than most real tasks, but we need to balance that with how wondrous it is. No one's watching No one watching or expecting narration. Candidate work in their own editor without distraction. Time for comprehension of tooling. Performance optimization require understanding existing system and sometimes building debugging tool. Both are hard to realistic to evaluate in normal 15-minute interviews. Compatibility with AI assistant. Anthropic general coding guidelines ask candidate to complete without AI unless indicated otherwise. For this take home, we explicitly indicate otherwise. Long horizontal problem are harder for AI to solve completely, so candidate can use AI tool as they would on the job while still needing to demonstrate their own skill. Beyond this format specific goal, I have applied principle I use when designing any interviews to make them take home. Representation of the real work. The problem should give candidate a taste of what the job actually involve. The take home should avoid problem that hinge on single insight where candidate and ensure candidate have many chance to show their full capabilities, leaving a little as possible to chance. It should have been by scoring distribution. People with good fundamental can learn specific on the job require narrative. I built a Python simulator for fake accelerator with characteristics that resemble TPUs. Candidate optimized code running on this machine using a hot reloading Perfetto trace that show every instruction similar to the tooling we have on Trainium. This machine includes the feature that make acceleration optimization interesting. Manu- Manually manage scratch pad memories, unlike CPU accelerator often require explicit memory management. Multiple execution unit running in parallel. I read aloud.
Designing AI-resistant technical evaluation.
Can we not?
Designing AI-resistant.
Can I not start from here?
But each new Claude model has forced us to redesign the test. When given the same time, the task is a parallel tree
This is too slow. I think this is.
traversal, deliberately not deep learning flavored, since most performance engineers hadn't worked on deep learning yet and could learn domain specifics on the job. He problem was inspired by branchless SIMD decision tree inference, a classical ML optimization challenge as a nod to the past, which only a few candidates had encountered before. The problem was inspired by branchless SIMD decision tree inference. Candidates start with a fully serial implementation and progressively exploit the machine's parallelism. The warm-up is multi-core parallelism. Then candidates choose whether to tackle SIMD vectorization or VLIW instruction packing. The original version also included a bug that candidates needed to debug first, exercising their ability to build tooling. Early results. The initial take-home worked well. One person from the Twitter batch scored substantially higher than everyone else. He started in early February, 2 weeks after our first hires through the standard pipeline. The test proved predictive. He immediately began optimizing kernels and found a workaround for a launch-blocking compiler bug involving tensor indexing math overflowing 32 bits. Over the next year and a half, about 1,000 candidates completed the take-home, and it helped us hire most of our current performance engineering team. It proved especially valuable for candidates with limited experience on paper. Several of our highest-performing engineers came directly from undergrad but showed enough skill on the take-home for us to hire confidently. Feedback was positive. Many candidates worked past the 4-hour limit because they were enjoying themselves. The strongest unlimited time submissions included full optimizing mini-compilers and several clever optimizations I hadn't anticipated. Then Claude Opus 4 defeated it. By May 2025, Claude 3.7 Sonnet had already crept up to the point where over 50% of candidates would have been better off delegating to Claude Code entirely. I then tested a pre-release version of Claude Opus 4 on the take-home. It came up with a more optimized solution than almost all humans did within the 4-hour limit. This wasn't my first interview defeated by a Claude model. I designed a live interview question in 2023 specifically, because our questions at the time were based around common tasks that early Claude models had lots of knowledge of and so could solve easily. I tried to design a question that required more problem-solving skill than knowledge, still based on a real, but niche, problem I'd solved at work. Claude 3 Opus beat part 1 of that question. Claude 3.5 Sonnet beat part 2. We still use it because our other live questions aren't AI-resistant either. For the take-home, there was a straightforward fix. The problem had far more depth than anyone could explore in 4 hours, so I used Claude Opus 4 to identify where it started struggling. That became the new starting point for version 2. I wrote cleaner starter code, added new machine features for more depth, and removed multi-core, which Claude had already solved and which only slowed down development loops without adding signal. I also shortened the time limit from 4 hours to 2 hours. I'd originally chosen 4 hours based on candidate feedback preferring less risk of getting sunk if they got stuck for a bit on a bug or confusion, but the scheduling overhead was causing multi-week delays in our pipeline. 2 hours is much easier to fit into a weekend. Version 2 emphasized clever optimization insights over debugging and code volume. It served us well for several months. Then Claude Opus 4.5 defeated that. When I tested a pre-release Claude Opus 4.5 checkpoint, I watched Claude Code work on the problem for 2 hours, gradually improving its solution. It solved the initial bottlenecks, implemented all the common micro-optimizations, and met our passing threshold in under an hour. Then it stopped, convinced it had hit an insurmountable memory bandwidth bottleneck. Most humans reach the same conclusion. But there are clever tricks that exploit the problem structure to work around that bottleneck. When I told Claude the cycle count it was possible to achieve, it thought for a while and found the trick. It then debugged, tuned, and implemented further optimizations. By the 2-hour mark, its score matched the best human performance within that time limit, and that human had made heavy use of Claude 4 with steering. We tried it out in our internal test time compute harness for more rigor and confirmed it could both beat humans in 2 hours and continue climbing with time. Post-launch, we even improved our harness in a generic way and got a higher score. I had a problem. We were about to release a model where the best strategy on our take-home would be delegating to Claude Code. Considering the options, some colleagues suggested banning AI assistants. I didn't want to do this. Beyond the enforcement challenges, I had a sense that given people continue to play a vital role in our work, I should be able to figure out some way for them to distinguish themselves in a setting with AI, like they'd have on the job. I didn't want to give in yet to the idea that humans only have an advantage on tasks longer than a few hours. Others suggested raising the bar to substantially outperform what Claude Code achieves alone. The concern here was that Claude works fast. Humans typically spend half the 2 hours reading and understanding the problem before they start optimizing. A human trying to steer Claude would likely be constantly behind, understanding what Claude did only after the fact. The dominant strategy might become sitting back and watching. Nowadays, performance engineers at Anthropic still have lots of work to do, but it looks more like tough debugging, systems design, performance analysis, figuring out how to verify the correctness of our systems, and figuring out how to make Claude's code simpler and more elegant. Unfortunately, these things are tough to test in an objective way without a lot of time or common context. It's always been hard to design interviews that represent the job, but now it's harder than ever. But I also worried if I invested in designing a new take-home, either Claude Opus 4.5 would solve that too, or it would become so challenging that it would be impossible for humans to complete in 2 hours. Attempt 1. A different optimization problem. I realized Claude could help me implement whatever I designed quickly, which motivated me to try developing a harder take-home. I chose a problem based on one of the trickier kernel optimizations I'd done at Anthropic, an efficient data transposition on 2D TPU registers while avoiding bank conflicts. I distilled it into a simpler problem on a simulated machine and had Claude implement the changes in under a day. Claude Opus 4.5 found a great optimization I hadn't even thought of. Through careful analysis, it realized it could transpose the entire computation rather than figuring out how to transpose the data, and it rewrote the whole program accordingly. In my real case, this wouldn't have worked, so I patched the problem to remove that approach. Claude then made progress, but couldn't find the most efficient solution. It seemed like I had my new problem. Now I just had to hope human candidates could get it fast enough. But I had some nagging doubt, so I double-checked using Claude Code's UltraThink feature with longer thinking budgets, and it solved it. It even knew the tricks for fixing bank conflicts. In hindsight, this wasn't the right problem to try. Engineers across many platforms have struggled with data transposition and bank conflicts, so Claude has substantial training data to draw on. While I'd found my solution from first principles, Claude could draw on a larger toolbox of experience. Attempt 2. Going weirder. I needed a problem where human reasoning could win over Claude's larger experience base, something sufficiently out of distribution. Unfortunately, this conflicted with my goal of being recognizably like the job. I thought about the most unusual optimization problems I'd enjoyed and landed on Zachtronics games. These programming puzzle games use unusual, highly constrained instruction sets that force you to program in unconventional ways. For example, in Shenzhen IO, programs are split across multiple communicating chips that each hold only about 10 instructions with 1 or 2 state registers. Clever optimization often involves encoding state into the instruction pointer or branch flags. I designed a new take-home consisting of puzzles using a tiny, heavily constrained instruction set, optimizing solutions for minimal instruction count. I implemented one medium-hard puzzle and tested it on Claude Opus 4.5. It failed. I filled out more puzzles and had colleagues verify that people less steeped in the problem than me could still outperform Claude. Unlike Zachtronics games, I intentionally provided no visualization or debugging tools.